Hey juniors, we're going to do our notes just a little bit differently. We're going to watch videos and then we're going to try to do practice in class. This is something that Mr. Hartz has been doing and I've done with my seniors, but I wanted to try it out with us and see what we think of it. So we're looking at Unit 3 still, polynomials, and the standard is 3.3 polynomial inequalities. Now we've been working on rational root theorem. That was our first standard. The second standard was with calculators. And the box problem, and we'll come back to that. But over this weekend, I want you to look at polynomial inequalities, because this is something that's really familiar, and we're just going to extend it in a little different way. So here's our first example. Graph the function f of x is greater than or equal to x over 2 plus 3. Now this is something that you should be very familiar with, so we're going to just run through it quickly, and then you'll have this in your notes. So we know how to graph this. We're in slope-intercept form. So we go up to 3, we plot our point. And we have a slope of 1/2, so we go up 1 over 2. And we continue this as far as we can. It's greater than or equal to, so it's a solid line. Solid line. We connect it. And then we need to test where are we shading this function. So typically we've tested the point 0, 0. So I'll plug in that point. I have 0. Is that greater than or equal to 0 over 2 plus 3, which is 3? 0 greater than or equal to 3? The answer is no. So therefore 0, 0 is not a point. So I would shade up here. Nice. Miss Stevens got an email. Cool. Okay, so that's the side that I would shade. Awesome. This is starting to come back. So let's try this one. Graph g of x is greater than or equal to x squared minus 4. Okay, so it's a little different question. We've got a quadratic that we're graphing. Well, we know how to graph that. So we'll go to -4. 1, 2, 3, 4. And we follow the same pattern we've been following. And it said greater than or equal to. So equal to means that we're going to have a solid line. Okay? And then we can do this the same way we've done before. So we're going to test a point. So if I tested 0, 0, 0, would 0 be greater than or equal to -4? The answer is yes. So I believe I'm going to shade on the inside of this parabola. Now if we tested a point on the outside, so if we tested like the point 1, 2, 3, 4. Let's say we tested 4, 0. Then let's see, our x was 4, so 4 squared, we'd get 16. 16 minus 4, we get 12. And then we had 0. So is 0 greater than or equal to 12? Well, no. 0 is less than 12. So that's why the ones on the outside, they wouldn't work. So we're shading on the inside here. Move this down. So that would be where my solution would be for that graph. And yes, this should continue up, but on your paper you probably didn't go much higher than that. So let's try one more. Graph. We've got the set of functions here. All right, so y is less than x squared plus 3. So let's graph that. We go up to 1, 2, 3. X squared, we go up 1 over 1, up 1, 2, 3 over 1. 1, 2, 3 over 1. And it's not equal to, so we do a dashed line. And for that one, we're going to test it. Is 0, 0, let's see, is 0 less than 3? The answer is yes. So am I going to shade on the inside or the outside of that? I'm going to shade on the outside. But let's just keep that in mind because we have another system, we have another equation in this system. So let's see, y is greater than or equal to x over 2 minus 1. So let's graph that. Minus 1, up 1 over 2, up 1 over 2. graph this one. Oh. Down over to. We can keep going. And this one had the equal to, so we're gonna connect these. Okay, and then let's test the point 0, 0. So is 0 greater than or equal to -1? Well, the answer is yes. So therefore, my graph is going to be above that line, but it's going to be below the parabola. So how this would look, if I looked at the whole thing, we can keep this going, is we would have this part shaded here. Good. So that part would be the shaded part. That would be my answer. Now let's try another one. What if I have this? Example 4. We're going to graph this. What if we have y is greater than x squared minus 2, and y is less than or equal to 2x plus 1. Okay, let's graph each of these. So the first one, y is greater than x squared minus 2. We start at -2. We have our parabola because the a value is 1. 1, 2, 3, 4, 5. And it's greater than, it doesn't have the equal to part, so we make it a dashed line. And then the next one, we start up at 1 and our slope is 2. So up 2 over 1. And then down 2 over 1. And this keeps going, and it's equal to, so we can make a solid line. Good? All right, so now we're going to try to figure out which section or what region will we use. So for the parabola, let's test the point 0, 0. So is 0 greater than 0 squared minus 2? So 0 greater than -2? The answer is yes. So we're going to shade inside of the parabola. But then we also have to keep in mind the other equation. So it says y is less than or equal to 2x plus 1. So let's try the point 0, 0. So is 0 less than or equal to 1? The answer is yes. So we're just below that. So it would be this region right here. Just this region we'd be looking at. And then we also have that dashed line, so remember that part. Now, something that we'll use this for as we keep going is, and something I want you to think about, is we have this shaded region. Now, what would happen, or what would it look like if I rotated it? So what would happen if I rotated this on an axis, or on the x-axis, or on the y-axis? How would that image look? So use that idea, bring these 4 examples to class, and I will see you then.